So in this one, we're looking to find the equation of a tangent to a curve, given the equation of the curve itself and at which point it meets. So what we need to do here is we need a couple of bits of information. Again, it's the equation of a line. So for the equation of a line, we need the gradient and we need a point on the line. We have a part of the point in terms of the x part of the coordinate. We can use that in the equation of the curve to find the y part of the coordinate. We've got that chunk of information. We then have to find the gradient. Now normally gradient is found using 2 points on a line, but in this case we don't have a second point. However, gradient can also be calculated using the rate of change of the curve, i.e. the derivative. So what we can do is calculate derivative at the given point where x is equal to 1. That'll give me the gradient of my line. I can then use that back into the equation and take it from there. So let's break this down and do it. First things first, let's find the full coordinate. So I know I've got x is equal to 1. So to find the y, I substitute it in and I get 2 times 1 to the power of 5. Take away 3 times 1. So that's 2 minus 3, so it's negative 1. So my coordinate, full coordinate, where the tangent touches the curve, is 1, negative 1. Second thing I do is I then take the derivative of the curve's equation, so dy by dx, and that in this case gives me 10 x to the power of 4 minus 3. Now, sometimes people might be tempted to set that equal to 0 and solve it like we've done in the past, and it's an understandable way to think, but you have to remember that's for solving for stationary points. That's not for finding a gradient. For finding a gradient, all we do is we substitute in the x value we know, and we find out what we're after. So what we can say is find therefore the gradient is equal to the derivative dy by dx when x is equal to 1. So in this case, I get 10 times 1 to the power of 4, take away 3, so my gradient then is equal to 7. Now, I just use this all in my format for my equation of a straight line, and I'll get a solution out. So I've got my y minus b equals m bracket x minus a. Substituting in the values, I get y take away negative 1 is equal to 7 bracket x minus 1. Playing about with that, you get y plus 1 equals 7x minus 7. Y equals 7x minus 8. There you go. Equation of the tangent to the curve at the point where x is equal to 1. It's a fairly straightforward standard set of steps for a question like this. We always have to get the same bits of information and we always look to calculate them in the same manner. And it typically is worth the same. So this is worth 4 marks here. We get 1 mark for finding the full coordinate. We get a second mark for differentiating and realising that's how we get the gradient. We get a third mark for finding the numerical value of the gradient by substituting in the x equal to 1. And then our final mark is given to us by that, the full equation of the straight line, i.e. the tangent to the curve at the point when x is equal to 1. If we remember these set of steps, like I say, it's a fairly standard set of steps to follow for a question like this, you'll nail it every single time. It's easy peasy, lemon squeezy.